This next mini lecture is on a topic that's always been fascinating to me as someone who's lived in the desert Southwest for a while. And the topic is monsoons. And so we're going to talk a little bit about what causes monsoons and start off with a more general explanation. And we're going to look at the moving tropical rain belt. So as we discussed in some previous mini lectures, we saw that the Earth heats up along the equator more than it does in the other parts of the globe because that's where the sun's radiation is the most intense. And so this causes evaporation to occur along that belt of the equator and then precipitation as a result, as it spills out around the equator. So we also discussed the fact that the Earth is on a tilt, and so sometimes when the Earth is tilted such that the northern hemisphere is tilted towards the sun, so in our summer, then the heating is going to be more intense during that summer season, and so it's going to not be right at the equator, but north of the equator if for the northern hemisphere. So as the Earth goes around the sun and the seasons change, this causes the tropical rain belt to shift. So in the summer, for the northern hemisphere, it's going to shift north. And so May through June, it's that tropical rain belt is shifting up to the northern hemisphere. Then in November and December, that tropical rain belt shifts south of the equator into the southern hemisphere. So as this rain belt moves around, it causes monsoon rains, and there's many different parts of the world that receive monsoon rains. In the northern hemisphere, in the summertime, some places that have strong monsoons are India, Southeast Asia, Southeast China, and then we also have them in the desert southwestern United States. In the southern hemisphere, in their summer, which is our winter, areas such as Australia, South America, and Africa, those continents all and countries all have some kind of monsoon activity. Okay, so I'm going to try and shift out of here to show you a really quick movie of this, hopefully. Okay, so in this movie, this is showing the rain belts. You can watch this blue band of rain as it moves up in the summer for the northern hemisphere, and then it'll move south of the equator for the southern hemisphere summer. So you can see that's how the rain belt moves up and down. Okay, so back to our PowerPoint. So just a little bit of background information about monsoons. The word monsoon comes from the Arabic word mawsim, which means season. And so it was first used to describe trade winds over Asia in the summertime. And these trade winds brought torrential rains, and they still do. But now this term has become more general, and it covers all of the different monsoons around the world and all the different areas that we've discussed. So again, why does this happen? We talked about differential heating. So the wherever the sun is the most intense, so if that's in the summer in the northern hemisphere, it's going to cause the Earth to heat up, the land surface to heat up more quickly than water heats up. That causes that hot air to rise, and as that hot air rises off the land surface, then moisture and some moist and cooler air from the ocean nearby is going to be pulled into that area to fill in as the hot air that was over the land surface rises up, and so it's going to bring in humid, cooler air. As these hot, dry, and cool, moist air masses collide, this leads to thunderstorms, rainfall, and humid conditions on land. And we see the biggest monsoon activity in areas where you have large elevated land masses that are near ocean systems or oceans or large seas. Okay, so India is famous for its monsoons, and that's because India is a large landmass with a very high elevation. and the center of the country, and then they also are surrounded by ocean. And so it's perfect ingredients for a monsoon. So in this map, it's vaguely outlined. This is the country of India, the bottom peninsula of it, and that's the whole country. And you can see in their dry season, what's considered winter, the air is cool, the air over the landmass is cool, and so it's kind of settles in, you get high pressure building up, and so actually the air is going to travel from landmass out into the ocean. So the air is traveling out to sea. In the summer, the reverse happens. The landmass heats up much more quickly than the ocean surrounding it, and then you have these high mountain ranges up in the northern part. And so there's a huge elevation change as you go onto the continent. And so the air masses heat up, they rise as they travel up the mountains. And so that's going to pull in all of this moisture from the ocean. As this moisture comes in, it rises up on the landmass as well. It cools very quickly, and then you get these torrential rains coming down. Okay, we have a similar system in the desert southwest. It's not nearly as strong as the Indian monsoon, but we do have a monsoon in North America. It occurs in mid to late summer. It's not a continuous rain, but it does account for a large amount of the precipitation that the desert southwest receives, so up to about half of the annual precipitation for the southwestern United States. There's a huge variation in the amount of precipitation these areas get from year to year. So some years we'll have a strong monsoon season and we'll get maybe 7 inches in the desert southwest. And then other monsoon seasons, they won't be so great and there will be 3 or 4 inches. Or even less, depending on where you live. So the same system happens here. These land masses, there's a big elevation change over Arizona and New Mexico. This area that's kind of brownish, there's higher mountains here, and these are lower lying plains. So the landmass heats up very quickly, the hot air rises and pulls in this moisture from the Gulf of Mexico and the Gulf of California, and as that moist air rises up from the plains onto the higher mountain areas, it cools quickly and you get a lot of precipitation falling out of those clouds. Okay, that's the end of the monsoon mini lecture.